Okay. Apologies for the small delay, but yeah, so today is a good session on 3D printing in product design, and we've invited Mr. Kishor Gopal Tikale, who's an associate professor at UPES, to join us for this and lead us into this new session. Now, the Design Nuances Edu series is a series where we talk about a specific topic by an expert in that area. So every week we refer to a specific topic, we learn something new, and what happens is this helps us get a better and deeper understanding of the overall world of design and fashion and architecture. Now, it's important that um, I may be interested in fashion design, but it's important for me to attend this workshop on 3D printing, right? Because you never know, it's knowledge that comes to you, it's awareness that comes to you, and that awareness is critical for your overall growth. Um, Now, as far as UPS goes, Professor Kishor Tikale is an associate professor with UPS. He's completed his master's in product design from IISc Bangalore after his engineering from Nagpur University. Now, he spent about 14 years with General Motors as a digital sculptor. All right. Um, and I don't know, when did you start at General Motors, Kishore?
2005.
2005. So we would have been at the same time in General Motors then. I was there from 2006 till 2008. Yeah. All right. So we
Wow.
were probably there, but I was not in the design department. I was in the
Mm-hmm.
engineering department.
Yeah, yeah.
And Kishore has also worked with Reva Electrica company, Videocon, and other um, companies he's been associated with. But in the last 2 years, he's worked in the transportation and mobility division of UPES, the handling that. So digital sculpting, transportation design, and product design are the areas that he's specialized in. So thanks so much for coming in today, Professor Kishore. All right.
Thank you very much, Dion. Thanks for my introduction.
No
Uh,
problem. Couple
good
of
morning.
couple of things I want before you start. Couple of things I want to mention. If uh, anyone is interested in UPES, what they need to do is they need to go into DQ Edge. You will find this school listed there, and you can find details about the school, and you can apply or inquire from here, and the right person from that school will get back with you. All right. Now, just so so everyone is on the same page, we spend about 15 minutes now giving instructions and information, and and Professor Kishore will talk about the topic for about 30 to 40 minutes, and then followed by a Q&A. Please make sure that everyone's microphones are on mute, and you'll type in your answers or questions or comments, and I'll try and moderate these questions at one shot. However, if you'd like to speak, you're most welcome to speak. But please raise your hand first, and then we'll give you an opportunity to speak as well. Um, as far as the design hackathon is concerned, a small update on this: the design hackathon, the dates have been postponed. There have been tremendous requests from students because the hackathon is clashing with their pre-board exams. So they've requested us to move the dates ahead. But it's still going to happen. It's probably at the end of November or beginning of December. We'll let you know depending on the CBSE exam schedule. But it's a very interesting event happening with it's good for all students to participate, and we'd be happy if as many students select the categories listed here and they participate accordingly. And yeah, so now over to the session with Professor Kishore. Right,
Thank
Professor,
you, Dion.
I've given you access to share your screen as well.
Thank you very much, Dion. I think it will be good idea if we play video of UPES first.
Sure.
The links are sent to you by Mr. Lakshmi.
Just hold on.
Yeah, can you?
Just give me 1 second.
Shall I share?
No, I've got it here. I just need to make sure that the sound settings are um, speakers. I'll just make sure that the audio settings, you can see my speaker, right? My screen, right?
Yes.
All right, all right. Just share sound. Okay. I'll
Prepare for a degree, but also prepare to become the most sought after. Prepare for assessment, but also prepare for when everyone will seek your time. Prepare for a career, but also prepare for a time when no one will need to ask for your resume. Prepare for the syllabus, but also prepare for a time when the world will learn from you. At UPES, we are as much about learning from the pages as we are about learning from the pages of life. We are as much about learning from the desk as we are about learning from the soil. When you come here, you prepare for success. You prepare for glory. You prepare for life.
All right, so that was one. I'll just share the other one as well. Okay, let me know if
When you are born, you don't know what's out there. You get exposed to the rapidly transforming world and are taught how to make a living and excel in the chosen profession. But are you taught how to live a long, happy and healthy life? Are you prepared for life? UPS launches School for Life, a movement to steer students' transformation and help education attain its higher purpose. We help our students become the best version of themselves, improve their relationships, prepare for future of work, act with empathy and live a more fulfilled life. UPS through School for Life continues to develop world-class professionals who are also nurtured to become entrepreneurs, problem solvers and above all, good human beings supporting environment, society and world at large. Come join the unique learning experience. Be prepared for life.
all right. Another couple of videos, I think.
I think one more. Yeah, one more video is there.
Okay.
My parents told me that why don't you give it a try. So we came all the way from New Delhi to Dehradun just to see the campus. And as soon as I entered through the gates, I just felt this kind of warmth and kind of a really sweet feeling that I belong here. That's how I knew that this is where I want to be.
It's in this beautiful location up in the northern mountains of India. You have the start of the Himalayas in the background, and so it's something quite serene about it. Like, I go to the lab, I spend hours working in the lab all day, and then as I'm walking back to my room, I witness the Himalayas and all the forests and the beauty that it is. And there's something quite serene and special about that.
The people here, the seniors, everyone, the faculty, they're also helpful that they made me feel that I have already been a part of this university. They didn't make me feel that I'm an outsider, I'm a newcomer.
The entire campus is filled with, life. You have cafeteria where the students chill, they spend time in between their breaks. You have got the amphitheaters where students practice or just have their little jamming sessions.
With regard to the facilities and stuff like that, I mean, all the labs here are on par or better than what I could expect back home. So there's been no shortage of equipment or any sort of technical issues that I've encountered while being here.
Some have been placed in TI cycles, someone went to General Motors, so yeah, looks bright, the future looks bright.
So CANSAT is the annual Design, Build and Fly competition, which is organized by a lot of prestigious, organizations like NASA, JPL. So yes, it was again a big experience, and after we won, we cannot express the happiness, the pride that we have with us right now to have represented our university, to have represented the entire country in USA.
So I feel secure because if you're going and competing with the students of the renowned universities and then we're beating them and coming up to competitions and challenges, that is where I feel secure because we are doing better than them in the sectors that they think they are good at.
Oh, it's been amazing. I've been blown away by the quality of UPS.
Extraordinary. Just one word, that's it.
Extremely good vibes. I don't know. Oh, or maybe supercalifragilisticexpialidocious.
Life at UPES is the one that every student wishes for, but not everyone gets it.
Thank you, Dion. Thank you very much for playing those videos.
Problem. And if you all want to know more, you all can always connect with Lakshmikant, who's here on this on the session, and he shared his contact details in the chat. Right. Over to you, Kishor.
Thank you very much, Dion. Good morning, students.
Good morning, sir.
Good morning, everyone who has joined here. I will be taking you through an introduction of 3D printing. Let me share my screen.
Yeah, it's visible.
Yeah. Okay, so today's topic is 3D printing in product design. So before we, just a minute, how I get rid of the top. Yeah, that should work. So before we get into what is 3D printing and everything, introductory session about it, I would like to talk about what is product design. Okay. So students, we all see a lot of product everywhere around us. All these products are designed by someone, designed by a designer. Okay, all this, each and every one of this product has to function, do its function what is intended for, has to communicate to the user. All these products have to look good, and they should be safe to handle, fine, and to get everything properly, the designer has to do a lot of thinking behind it. Okay, so there goes a lot of sketching and iterations, and making it in physical, that is prototyping we call it, and testing it. Okay, checking whether it is working fine. If it is not working fine, do modification to the design, make prototype again. Okay, so that is the product design for you, right? The product design process is you have to empathize, get to know what the problem is, define your problem properly, make a lot of ideation sketches, and then make prototypes of the product. So what is prototype? Prototype is something that is not to be used but to be tested. How the product, it will give you idea of how the product is going to work in real life. If there are any problem with safety or something, then we have to change the design. Okay, so prototyping is very important uh, phase of product design process, and this is where we pitch in. We use 3D printing. Traditionally, making prototypes, physical prototypes is a very skillful job, and lot of it is costly, and it is time consuming, and this is where we are making use of 3D printing in product design process. Fine. So 3D printing makes prototyping easy and inexpensive. Not only prototyping, but also 3D printing is ideal for making small scale production. If you have to make, say, 20 to 50 pieces of a product, then you can't go for the traditional method of making molds and injection molding process, because molding takes lots and lot of, it's very expensive, takes a lot of cost. Fine. So that's where 3D printing comes handy. It is fast, it is cost effective. So now we'll talk about 3D printing, its types, and moreover, everything about it. So 3D printing, it is also known as additive manufacturing. It is a method of creating three-dimensional object layer by layer using a computer created design. So basically you have a computer model that you are converting into physical model. It is done by 3D printing. 3D printing is it is done by 3D printer. 3D printing is additive process whereby layers of material are built up to create 3D part. This is opposite to subtractive manufacturing process. Traditionally, we have subtractive manufacturing process, means we have a block which we keep on cutting till we get the shape that we want. But 3D printing is additive. Okay, you keep on adding material till you get the shape that you want. 3D printing creates less, is one of the advantages, less material wastage. And this is how it looks. The printed parts can be very, very complicated, very, very complex structures. The parts are possible in 3D printing, which would never be possible in any other manufacturing processes. Okay. So you can see the amount of complexity that all these products require. Now coming to the working principle of how a 3D printer works. Okay, most of you or all of you must be having printer in your house, which you connect to the laptop. Okay, and it gives print. Fine. So you need to have soft copy. The printer converts your soft copy into physical, print on physical paper. Fine. But what you get on paper is two-dimensional. But what if you have three-dimensional model and a 3D printer, and what you get is physical model? That is how what the 3D printer is. And how does it work? 3D model is a three-dimensional model. It has X, Y, Z, all three axes, material on three axes. What if you slice the 3D model in different layer? Okay, what you get are two-dimensional layers. Fine, two-dimensional layers. Each layer can be further divided into lines, and these lines can be easily printed using a computer. It is just like using 2D, here also in paper printer also we get 2D lines printed by a head that is in 3D. So this is finally what you get is physical, product. So all these things are done in the software that is called Slicer. Fine. Slicer sends this information to 3D printer, which then makes a 3D model. So this is the idea of how the principle behind how 3D printers work. Now coming to more physical part of it. I mean, understandable part. We have computer data in our computer, right? That we have to convert into STL file, the file that is readable by Slicer software. So there comes Slicer software between this. Slicer software uses .stl file and converts it into G code. G code is the file which has all the information of how the head will move. 3D printer head will move all along. Fine. So STL file is broken into lines and paths. Fine. This information goes to a 3D printer, and which then gives us the printed object. So got it? We need to have a software in which we can make a 3D design. Then we need to convert it into STL file, which is converted by a slicer program to G-code file, which goes to 3D printer, which gives us printed object. How our CAD file looks, it looks something like this. And what we get is printed object. So it is just like our regular printer, right? Hope you understood this. Now, we'll touch upon the history of the 3D printer for a brief, because although we feel that 3D printing is very new phenomena, new technology, it's not like that. It started way back in 1983 when Chuck Hull invented a stereolithography apparatus that's called SLA. So that is the first invention in 3D printing. Then in 87, Carl Descartes files patent for SLS technology, that is selective laser sintering. We'll see in coming slides. And in 88, we got our first commercial rapid prototyping printer. So 3D printing is also called rapid prototyping because of the speed it has. Then in another very important thing happened in 89, that Scott Crumb files for patent for fused deposition modeling. That's called FDM, which became very, very important. I mean, widely used technology. Fine. Then 3D printed organ transfer technology. In medical also they started using 3D printing. First animal kidney was printed in 2002. In 2009, patent of FDM, that Scott Crumb got patent, that expired, and it opened up a lot of for wide audience. They could use FDM, and the cost of this thing, FDM technology, came down drastically. And again, some more innovations in medical we can talk about. And somebody in 2014 got a 3D printed skull transplant in Norway. Okay, so these are important milestones. Most important people who contributed to the technology are Chuck Hull, Carl Descartes, and Scott Crumb. Application, as we know, lot of it is getting being applied in lots and lots of industry, lot of areas. As we all know, product design is one area which is where it is widely used because of sheer prototyping requirement and all. In game design, what you sketch, what you have to physically check it. So game design, why this is widely being used. In jewelry, where we have intricate details which are difficult to be replicated by other technologies, widely used in jewelry. And in transportation, we had this is world's first 3D printed car and working prototype. So transportation design also we are using very much. In medical field, the application is increasing day by day. Already we are making bone transplant and things like that. It's called transplant. We are on the way to making tissues, living tissues, and making organs. So still long way to go, but we are on the path. And in prosthetics, it is already being used very widely. In prosthetic, what happens, every person has different requirements. So you can't make it standard, standard that all these 50 people will be having same leg. No, prosthetics 3D printing delivers to individual requirement. You can make prosthetics for individual requirement. Then in construction, we are seeing a lot of use of 3D printing can be used, and big construction houses in India. L&T made first 3D printed house somewhere. I don't remember. In education, we are making models, 3D models, so children can, students can properly get to understand the material, understand the which they will not have which otherwise they will not have access to, right? And also in food industry, also 3D printing in being used. Already there are few restaurants in the world, one in few in USA, one in Britain, one in Spain. They are 3D printing all their food with 3D print. All their food, and giving the customers. Okay, so it's very advantageous. A lot of advantages we have. There are some disadvantages. So let us see one by one. Advantages are it is fast. Now we are comparing with regular method of prototype, like say 3D mold. If we have to injection mold or cast, then we have to make molds. Now making mold takes a lot of time, right? So 3D printing is fast. Compared to that, 3D printing is flexible. We have seen the images where very complex shapes are we are able to print. Suppose there is an aluminum block in which it is required to there has to be a lot of channels for passing cooling water, coolants and all. So such complex shape are not possible in the other methods, but are possible in 3D printing. Then it is cost effective as well, especially making molds, steel molds or aluminum are huge expense for a company or for an industry. So you are replacing that. Print on demand. The designs can be made for individual taste, individual requirements. Strong and lightweight parts, right? So we can make very lightweight parts by using some of the technologies, and low wastage. Okay, so these are the advantages. There are some disadvantages as well, like we can't 3D print every material. Okay, although there are good amount of study has been done, and a lot of material we are able to print. We are able to print polymers. We are able to print metals, ceramics, rubber, etc. But still, it's limited compared to other. Restricted build size. Most 3D printer come with a size limitation. And if you want to print a 3D house, you have to make a special apparatus, special printer for that. Okay. Post processing. When you 3D print some this thing design, there's a lot of post processing. You have to remove the support material. You have to finish it. You have to give different kind of finishing. I mean, the finishing is not as good as you will get in injection molding also. Suitable for low volumes. You can't have high volume production in 3D printing. That is the biggest disadvantage that 3D printing has. If you want, if you want to make, say, laptop covers of some 5,000, then 3D printing is not the way to go. Okay, so you can have for 20, 30, 50 number of things, 3D printing is good. And then there is a low strength. The product that you get from 3D printing has low strength. Some additional sometimes process are done to strengthen the product, but yeah, so it's good for prototyping, testing, etc. But we have to gear up to make it more constant research in going on in this area. Now, coming to little bit of technical part of the 3D printing, and there are types of 3D printing. So 3D printing, there are 7 identified types of 3D printing. Will not go through every of them, but mostly 3D printing can be grouped into, say, additive processes, solidifying processes, lamination, kind of. Okay. In additive processes, you are adding layer by layer. So there are 2 types of 3D printing that uses additive process. One is fused deposition modeling, that is FDM, and one is material jet. FDM is very popular, very popular. They mostly use polymer. Okay. All this domestic 3D printing, 3D printer, we use FDM, that is the FDM process. Then there is material jet, which uses wax or some polymers. And in solidifying processes, we have the technologies like SLS, BJ, and SLA. SLS is selective laser sintering. Then we have binder jetting and stereolithography, SLA. SLS uses polymer, ceramic, rubber, glass, metal, etc. All these can be used in SLS. Binder jetting, polymer, metal, both can be used, and stereolithography, polymers are used. So few of these technologies will try to go into details of this FDM, fused deposition modeling, how it works. Okay, so you can see the mostly the 3D printers look like this, where there is a bed and there is a head. We call it a printing head, which moves in X and Y direction, or it moves in X direction and the bed moves in Y direction. Fine. So depending on the instruction, the printer gets the instruction from the software and moves accordingly to print the model layer by layer. Okay, so first of all, base layer is done, then above that and above that. So layer by layer, the product is completed. Now the product is many times, most of the times, products are complex. They have cantilever. This cantilever structure can fall. So because of that, the 3D printer calculates how much support is required and gives the support material. So support material and printing material are different in density. Okay, so support material, as you see, it is just there to give support. These are very these are not dense and can be will be removed after the printing is done. So here we are seeing a schematic of head of filament. Polymer filament is supplied through the head and it is heated in the head, and layers are deposited one by one. Fine, this is how it works. And it is most common FDM for especially for domestic purpose. Layer by layer deposition of polymer. This was invented by Scott Crumb, who started Stratasys company, which is one of the foremost 3D printing companies. Then FDM is cost effective and large products are possible. We have seen that FDM process is used in construction, making houses, right? Then next is stereolithography, SLA. It's called SLA. This is the next widely used technology in which there is a resin. There is a polymer resin which is in a tub, in a container like thing, and there is a laser source. The laser source is directed by XY scanning mirror wherever you want resin to be cured. Okay, so UV rays curable resin. This is UV rays curable resin, which cures means solidifies layer one by one, and the bed moves down, one by one. After each layer, bed moves down. So this layer is made, bed moves down, then this layer is made, then this layer. So like that, the resin is cured by using UV laser source. This is more accurate than FDM. Polymer is melted to semi-liquid form. UV laser UV laser when contacted with polymer converts liquid into polymer, converts the liquid polymer into hard solid. This is more accurate and gives good finish, and widely used in aerospace, automotive, and medical industries. So industry people use SLAs more. Medical is mostly used in medical. Then comes selective laser sintering, SLS. SLS is similar to SLA, the one which we have seen earlier, but instead of liquid polymer, it is a powder that is used. Right? Powder is melted by high intensity laser to make a layer. Now you can see the schematic here. So this is a powder, this is a bed, this is powder, and this is part which is being made. The laser is directed to the powder by a mirror, the mirror that takes instructions from the software, okay, which all area to be cured, okay. And wherever the laser falls, that powder gets sintered, that the powder is melted a little bit because of heat, and it deposits, okay. So this is how it works. With every layer, platform moves down and new powder layer added. So one layer is done, platform moves down. This is another container which is having powder. So when the layer moves down, a roller or scraper scrapes the powder over this. Okay, so new layer of powder is done. That is sintered, and this come down. Then new layer is added. This bed goes up, this bed comes down. It uses a wide variety of material like nylon powder, ceramic, rubber, glass, metal, etc. And it has got very good precision. So because of precisions, this SLS and SLA are used widely. The next one is binder jetting that we'll talk about. It is similar to SLS that we have seen just now. But the powder is bound together using binder agent. Fine. Here, the powder was melted by laser. Here, the same powder, same mechanism, same feeder mechanism is there. Just that the powder is not, it doesn't use laser, but it uses binder. Binder means adhesive. So there is a container of adhesive which is sprinkled or flown by a head. Okay, this head moves according to the design and sprays the binder in the areas wherever the powder has to be solidified. Right? That happens layer by layer. The powder is layer of powder is added. It is sintered by binder. Another layer added. Likewise, it goes. The commonly used material are metal, sand, and ceramic. This is used for making sand casting, cores, and molds. So this doesn't give very good finish. There has to be some post processing. Actually, a lot of post processing is done to get the proper material. This is cost effective and mainly used for sand casting, cores, and mold, making molds. Okay. Then one more we have, that is polyjet, material jet. Polyjet or called material jet. It uses wax mostly or nylon polymers also sometimes, but uses wax material. Hot wax drops are deposited and cured by UV laser. High resolution parts, it gives very good resolution parts. Okay, so it can use polyjet. I mean, different material can be used to have in the product, okay, which requires different material like this can be done in polyjet. And material are, you can see the inkjet print heads, and part is being made one by layer by layer. Because of the high precision, high resolution, it is used in dental and jewelry industries. And the product that, the end product that we get from printer is a wax model. And wax model can be used for lost wax process to cast in other material. Fine. So you would be knowing lost wax process. So wax is this wax model is used for making mold, a ceramic mold, and the wax is melted out. You are remained with mold in which you can pour another material to get that shape. Okay. So I'm not including all of the technologies, just the main ones. And let us move to next topic, that is material that are used in 3D printing. So as we see in all the printing processes, we need filament, those material. So especially polymer material, there is wide variety of material that we can use. They are readily available. Although 3D printing can be done from thermoplastics, metal, resins can be used, ceramics can be used, rubber can be used. But in thermoplastics also we have wood also can be used. Right? Major material that are used in printing are PLA, ABS, and nylon. And wood, other things also are also used. The flexible is another major material that are used. it is nothing but the mixture of polymer and rubber, which gives you that elasticity in the final model. If you have the requirement that the final model has to have some elasticity, okay, then what you use is the material, flexible material.
Professor, just to keep a track of time, it's 10:13 now,
Okay.
and we need to keep some time for Q&A as well. There are some questions coming in.
Yeah, I will be completing shortly. It
All
won't take
right.
much time. Yeah.
All right.
Okay, so major material, as I said, are ABS, PLA, and nylon. ABS are mostly we use PLA, other than other materials. In our domestic use prototyping, we use PLA, and after that mostly used ABS. So ABS is low cost, widely available, strong, and it has better finish. The problem with ABS are heavy warping and shrinkage, needs heated bed. It gives toxic fumes and smells bad while in motion. PLA are wonderful material. PLA is polylactic acid. Yeah, and it is a biodegradable material made from starch, sugar, rice starch, sugar starch, and all. So biomaterial, low cost, low warping, good strength, and good dimensional accuracy, good shelf life. However, these are not good for, not suitable for outdoors, and they have low heat resistance. Nylon is another material which is durable, strong, and flexible, and they have little warpage. However, nylon is hygroscopic. That means it takes humidity from the atmosphere and loses its shape. So in humid atmosphere, nylon are not good, and they are less precise. Okay, so mostly ABS and PLA are used. CAD and slicing softwares. So there are different softwares for CAD, making the model, and then slicing. Slicing softwares means, as I said, the interface between CAD model and the 3D printer. These are the CAD models that are most, that you can readily use. These are very easy to learn. However, there are many more CAD softwares that you can do wonders with, but these are the ones which are easy to get and easy to learn. Google SketchUp, Fusion 360, Tinkercad, FreeCAD, etc. Google SketchUp and Tinkercad are, I think, online software. So you don't have to download and install, but you can make things and readily they can be printed. Then there are slicing software. Cura is used more. Cura is from Ultimaker, which is a big 3D printing company. Then we have Makerware, Simply Pretty, Slice 3R, which are really good software for slicing. You can check your model slice by slice, how it works, etc. How the supporting, how the model will be supported. Everything you can, everything will be displayed to you before printing through these softwares. If you wonder how do I make CAD models, 3D modeling, no problem. You can get 3D. You can download the 3D models from different online repositories like Thingiverse, My Mini Factory, Yegi, Fab 365. So there are many. These are prominent ones. You can readily. Some are free and some are you have to pay some pay for using those models, downloading the models. I have some links posted here, which I will be sending to you in case you'd like to learn more. And yeah, that is all I have for this presentation. Thank you very much. We can have question answer session. If you have any questions, please let me know.
All right. Thanks. Right. So there are thanks for that, Professor Kishore. You've covered some very important topics there. So there's a question from Stephen Samuel who's saying, if I wanted to make a 3D printing of a car and if it should have seats inside, how do I give the details of the inner part of the car to the 3D printer since it will not be visible from the outside?
Okay, what I understood is your question is like the car has exterior as well as interior, right? See, if it is a small model, whatever you make in CAD, that you can get printed. So you don't have to worry about you make a car, you make a seat inside the car, you make IP dash steering, everything you make in the model, 3D model it. And when you give this 3D model to 3D printer, you will get everything printed. You don't have to worry about whether how to, the other way is, of course, to make seats separately, make dash separately, make exterior separately, make interior separately. Okay, that also is one method that people follow, and even you can have everything printed in one go. Okay, just you have to make sure that you have to have opening to scrape out the support material. That is the only thing that you have to take care of when you.
All right. Stephen wants to follow it up with a question. Stephen, go ahead.
I was just asking because I was wondering how you would like, if you want to make it's like a toy car and then you want the pedals also to be there at the bottom, then that won't come inside the picture, right? Like if you want the pedals and the steering wheel and all those will be blocked by the front view of the car. So when you take a 3D printing, how do you get those inside the image? Like the 3D print?
Yeah, I understood your question. My answer is you can print everything in one go. Just that you have to have some opening to scrape out the support material. There are two material in 3D printing. One is which your product is made, the material by which. The other material is a mesh which support the cantilever and all. So this material you have to scrape out from somewhere. There should be some opening. So you have to plan that way. Okay, where from I will scrape out the material. Okay, if the windows are open, you can scrape out from windows, or you have to plan for it like the bottom floor, the complete bottom floor, you make in separate. You make that separately, so it can be like the interior is different and exterior is different and both are sitting together properly. Okay, this way you can. So a lot of thinking needs to go, a lot of planning also needs to go before you give for printing.
All right, thanks.
Yeah.
There's a question from Arvind. I'll come to you in a bit. We'll just take a couple of questions which are here.
Dion, I want to show something. Just give me 1 minute.
Sure.
Yeah. I think. Just give me 1 minute. As the question was related to how you do you have to make every part separately? No, you don't have to. Can you see this? This part was printed in one go. It has got this screw as well as, see, this screw is there. This part is there, which is inside the top part. So there are three different parts here, and all are, this is functional. Okay, and all are printed in one go. Okay, so I hope that answers your question.
Yeah, that's very interesting. Um, couple of questions from Aditya Sriram and probably Arvind as well. So which is better, SLA and or SLS? So that is one question. The second question is from Arvind. Is SLA used in all printing methods other than 3D printing?
What was the second question?
The second question is SLA used in all methods other than 3D printing?
SLA is no, it is only for 3D printing. I mean, it's not if you're saying 2D printing. No, it's for 3D printing only. And the first question was about SLA and SLS. So it which one to go for, it depends on what is the requirement. Both, although both give good finish, but mostly SLA is used polymer. SLA is in SLA it is polymer is melted in, it is a semi-liquid form. So mostly I think SLA is used rather than SLS. SLS still give you very that coarse finish is finish is not very good in SLS. In SLA, finish is really good. And if you are using say metal, then SLS you have to go for, and SLA is used for polymers. So that is the difference.
All right, Arvind, would you want to have a follow-up question? You had raised your hand earlier.
Actually, my question was like, sir, 3D printings are printings can be used in films.
Films means movies.
Yes, sir. Like what we could say, like modeling of that animal. Like if suppose I'm taking an example of Jungle Book film, in that the animals, like we need to give reality to that animal. So before that, we need to make a prototype of that. So whether 3D printing is used in that method.
Okay, 3D printing is used in every industry, and overall I'm saying that 3D printing is being used in every industry to make in the entertainment industry also. They make props and all using 3D. What you are saying, Jungle Book, there are some cases where 3D printing is used to make model. But then if you're talking about this animal and all, they are CAD models. They are not 3D printed. You know what I mean? Till you are able to, I mean, till the time this entertainment industry is able to make everything in virtually, if they are able to make everything virtually, show everything virtually using the video mixing, using the CAD models, till then they will not spend in physical models. Okay, but there might be some requirements where they have to print 3D, print the models, then they will go for 3D printing.
All right, so we'll take the last couple of questions as we are coming to the end of the session. So there's a question from Anand Kaushik. Does product design require engineering?
No.
I think
A
that's
product designer has to be, he has to be knowledgeable. I mean, awareness. He should have one awareness about everything, all sides. How the manufacturing, main things about manufacturing, the material. All these are very necessary for product design. The material manufacturing, little bit of engineering, but he doesn't have to be pro in engineering.
Yeah, so I think that question is something which is very widespread. A lot of students say, "Oh, if I want to become a transportation designer, I need to do my engineering, or if I want to design products, I need to do my engineering." But the thing is, being a designer, you need a design solving problem mindset, and the technical aspect does not matter here. If you don't have the knowledge, you acquire the knowledge, or you get someone who has the technical knowledge, right? But the designer would still follow the design process irrespective of what is being designed. So that's something which is very I like the question, because it's a question that's very relevant to this group and to all
Yes.
people. All right.
Yeah, yeah.
Finally, there's a question from Dhwani, who says, what will I use if I need about 100 units of my prototype for a user survey? What what will I use instead of 3D printers, as this is an example of high volume production?
Yeah. See, if the product are identical, all your 100 pieces are identical, you can go for, as I said, lost wax printing. That's what these batches, batch production, 100 200 pieces of production people will do. You print one product in 3D printer, okay, and this one product, um, it might be wax, it might be, sorry, you get it printed in wax, fine, and wax will be dipped in ceramic solution and heated. Then all the wax will uh, come down, means go away, and the shell is remaining. This shell is your mold. In this mold, you can pour any plastic, any polymer, and make the part 100 times. Okay, so that's how it is done. That is how they do actually. Lost wax process.
Thank you, sir. I understood.
Yeah, you can print even metal, and metal also are possible.
Right. So Sahu is asking if we will get the PPT as a reference. So Sahu, Professor Kishore is sending some reference links along with some details, so that will be shared with you all on the Design Nuance group. All right.
I will be sending the same PPT.
Oh,
Yeah.
fantastic! Then that'll be great. All right. So Professor Kishore, thank you so much for attending, and Lakshmikant, thank you so much for organizing, Professor Kishore. All right. And very nice session on 3D printing. All right. Thanks a lot for taking the time out to come here and talk to our students.
Thank you, Dion, for having me here, and thank you all the students for listening to me. Thank you very much. All the best to you.
All the best. Thank you, sir.
Thank you, Kishor sir. Thanks a lot for your time, and Mr. Young, thank you so much for your opportunity.
Sure.
So, in any questions or any queries, I've shared my number to the students. They can certainly refer to me.
Right.
We'll be more than happy to assist you. And as soon as I get a PPT, I will share it across so you can check.
Sure. And there's a question from Adriel Thomas, who says, I'm not in the Design Nuances group. Adriel, please connect with your student counselor, and they'll help you out. All right. Okay. Thank you.
Great.
Thanks,
Thank
everyone.
you. Thanks a lot for your time.
Thank you, Dion.
Kishor
Bye.
sir,
Bye.
thank
Bye,
you so
Namaste.
much for your time. Yeah, good day. Bye bye.